over 1 year. It will take about 2,000 to 3,000 years for it to do so. So it's a slow process. But then if we go to the question of the biggest piece of ice in the world, East Antarctica, which equivalates something like 80 meters of sea level rise, will this melt in the future? The answer is definitely no. The average temperature in East Antarctica is so much below zero that even if we got a greenhouse effect, say, an enhanced greenhouse effect that would equivalent 10 degrees change on average, it would not melt the East Antarctic ice sheet because it's so cold. What it would do instead would make the ice grow. And it would make the ice grow simply because when the Earth gets that much warmer, there will be so much more humidity in the atmosphere, and that will increase the snowfall in Antarctica significantly. So therefore, it sounds like a contradiction, but if we get a warmer climate, East Antarctica will grow.
The warmth of the tropical ocean generates enormous amounts of water vapor, which is distributed to the rest of the world and falls as rain or snow. So water vapor, clouds, and precipitation play a decisive role in the climate throughout the atmosphere. The United Nations Climate Panel bases its scenarios on what will happen if we double the amount of carbon dioxide in the atmosphere. This would not only result in a climatic disaster. The calculations say that more carbon dioxide would also increase the amount of water in the atmosphere. It is this cocktail, more carbon dioxide and water, that according to the theory must lead to a greenhouse effect many times as great as carbon dioxide on its own. The trouble is, temperature increases in the atmosphere just don't seem to have happened to the degree that the models predict.
A computer model is a very sophisticated computer program that attempts to simulate all of the processes associated with the atmosphere. In particular, therefore, what we need to have is as much data as possible to be able to fire the model, to be able to understand the processes. Generally, what we find is that many of the processes that work in the climate work at a variety of scales that a computer model simply cannot resolve. One of the things we do not do well in climate models is simulate precipitation. And again, precipitation is affected by virtually every component of the climate system, and in turn, every other component of the climate system affects precipitation. So precipitation is a very good diagnostic as to how well the climate model is doing. And most climate models don't do precipitation well at all. Hi, Dan.
Hey, Dave. How are you doing?
Okay.
Good.
Got this I want to show you.
Oh, okay. Let's take a
Our
look.
environmental network. A computer does only what it's programmed. And in particular, it is important, therefore, to program it correctly. The problem is we don't have perfect knowledge of how the Earth system operates. So therefore, we're working with an incomplete understanding base to try to put together what we know to see if it, in fact, generates the correct conditions.
All right, good.
Thank you.
Yep, see you later.
There's an old computer phrase that says garbage in, garbage out. And it's very important that we not only have data to drive the model, but that we also have an understanding of the processes that the model needs to simulate. As a result, if the climate model cannot simulate the current climate well enough, then we have a condition where we're trying to simulate the climate with a model that is imperfect.
Climate models can be thought of as a list of rules. And so this climate model, when it tries to predict the future, just follows specific rules. The real world is a physical system. It follows rules, but there are so many that are not contained in climate models that I think the climate models are too limited in being able to express what really happens in the real world. And so to use them for a long-term projection, I think, is not wise at this point.
Computer simulations are the tool that's used to make forecasts of temperature into the future. And the latest forecasts have a huge range. They range from just over 1 degree centigrade to, my goodness, almost 6 degrees centigrade for the next 100 years. That large range immediately tells you that the models don't agree with each other and they're very uncertain.
The Intergovernmental Panel on Climate Change and treaties such as the Kyoto Protocol are primarily based on climate model forecasts of what's going to happen in the future. Our issue associated with that then is if the climate models are somehow biased or incomplete, then our forecast of what the future might look like is too biased and incomplete.
Why that then turns into something that means there has to be action now, that's confusing to me. I can only imagine that something like the precautionary principle has been adopted as de facto policy.
The science in this case is indicating from incomplete models that we need to make political assertions and political changes. But part of the problem is that with incomplete science, we can make mistakes in policy that can have serious ramifications in the future.
When one talks about climate models and observations, I'm reminded of a climate scientist one time who said, "My model is right, it's the real world that's wrong." And I think that's what we've seen on many cases. And so using observations is not as exotic. It is not as dramatic in many cases, and occupies sort of a lower level in the climate hierarchy of who gets attention. Because climate modeling enterprises are very expensive, so they have these constituencies built up that seek to maintain their work. Observationalists generally do not have that same attention. And so developing observational data sets is sort of the weak sister in the climate community. Yet climate observations are supposed to represent the truth, not the theory, against which our theory is to be checked. I believe observations, and that this is where our basis for climate change should be understood and the perspective from which we should see the future. When you look at the past, I don't think the perspective of the future is all that bad. A finding such as ours that says the satellites show no real serious global warming is not well received in much of the climate community, and I recognize that. But it has never been a goal of mine to be part of the mainstream of the climate community. My goal has been to provide scientists and the world with the most accurate data possible that we can judge and understand what the planet is doing. And so the data and the results are often greeted with skepticism because so many people have a belief that global warming is going to be a disastrous thing and that it is occurring right now to a large extent, that this picture doesn't fit their picture of the world. And as a result, I've had a very interesting life dealing with controversies and so on.